In this video, we'll be learning how to factor a difference of perfect squares. Remember that in math language, difference means subtraction. So a difference of perfect squares is when two perfect squares are being subtracted from each other. A perfect square is any number that is the product of a number multiplied by itself. For example, a perfect square is 9, because 3 squared, or 3 times 3, is 9. 10 is not a perfect square because there's no number that if you multiply it by itself will give you 10. Now we need to list out all the perfect squares. So copy down everything that you see right now, and on your own fill in what all the perfect squares are. So fill in what 1 squared is, what 2 squared is, etc. Press pause now. Go ahead, press pause, check your answers, and fill in anything that you need to fill in. Press pause now. Terms with variables in them can also be perfect squares. This is the case if the exponent is even. So in all our examples, see that the exponent is even. 2, 6, and 10. Even, remember, means it can be divided by 2. However, if a term does not have an even exponent, like the invisible one here, 3 or 9, it is not a perfect square. Go ahead, press pause, and copy these down. Okay, so example 1 says x squared minus 81. Before we factor this, we need to make sure that it is a difference of perfect squares. So all the exponents, which is just this one right here, is 2, so that's even. 81 is a perfect square because 9 squared is 81. And it's subtraction, which means it's a difference. If it was adding, we couldn't factor it like how we're about to. So to factor a difference of perfect squares, first I want to make 2 sets of parentheses. One will have a plus sign in the middle, the other will have a minus sign. My first term is x squared. So I'm going to take the square root of it, and that square root will go in the first place of both of my binomials. So the square root of x squared is x. So I put x in the first spot for each one. Next I need to take the square root of 81. The square root of 81 is 9. So I put 9 in the second spot of each binomial. And that's my final answer. Notice that the two binomials look almost exactly the same. The only difference is that one has a plus sign and one has a minus sign. Press pause and get this copied down. Example 2. Let's see if it's a difference of perfect squares. So 16 is a perfect square because 4 squared is 16. I have subtraction, so it's a difference. And my exponent is even. So this is a perfect square, this is a perfect square, and there's subtraction. So again, I can make my 2 parentheses, one with the plus and the other with the minus. My first term was 16. The square root of 16 is 4. So I put 4 here and 4 here. The last term is x to the 6th. So I'm going to take the square root and it's going to go here and here. When we take the square root of a term with exponents, it's kind of like we share the exponent with each side. So it was a 6, so I'm going to have x to the third here and x to the third here. And this is my final answer. Press pause and go ahead and copy this down. Example 3 is 4y to the second minus 25. So the coefficient, my first number, is 4. That's a perfect square. My exponent is even. There's subtraction. And 25 is also a perfect square because 5 squared is 25. So this is a difference of perfect squared. So I go ahead and set up my 2 parentheses with a plus and a minus. Watch this carefully. In the first place I have 4y to the second. So I'm going to take the square root of that and it's going to get split in the first spot of both of these. I'm going to take it in 2 steps, do the number, and then the variable with the exponent. So the square root of 4 is 2, so I put 2 here. And the square root of y squared is just y. so I put 2y here. And I needed the same thing in the first place of my other binomial, so I'll put 2y. Make sure both the 2 and the y are going in the first spot because they came from the first term, so they have to go in the first spot. And then for the last spot, I just have to take the square root of 25, which is 5. So 5 goes in the last spot, and this is my final answer. Press pause and copy this down. We have now finished all of our examples, so you may go on to the practice. Good luck.